In this section of 1.4, we will be talking about parallel and perpendicular lines. Let's start by talking about parallel lines. We say that if we have two distinct non-vertical lines are parallel if and only if they have the same slope. So it is very important that when you are asked to find a line that is parallel to another line, that their slope must be the same. If their slope is not the same, then those two lines are not parallel. At some point they will intersect. They may intersect if the slope is not the same. So let's have an example. We have on the right hand side, I already drew a line, and we'll say that this line right here, it's in the standard form of let me just rewrite this again. This is in the form of negative 3x plus 2y equals to 6. So that is the standard form of the equation of this line. And we're asked to find a parallel line that passes through the points 6, 3. So again, we give it an equation, 3x plus 2y equals to 6, and we are asked to find the equation of a parallel line that passes through the points actually with the coordinates 6, 3. Now if you notice, we can simply graph, let me choose red, and graph a line. So for a line to be parallel, roughly we can say that it will look something like this, right? That looks parallel. But to be sure that it's parallel, we actually have to use the equation. Now, when you are given the standard form of an equation, it's not that helpful, so you may want to change it to y-intercept form. This is one of the ways that you could do it. There are other ways, but I think this is my favorite way to find a parallel line if you are given first a standard equation, a standard form of the equation of a line. So I'm going to go ahead and I'm going to solve for y. Change back to blue. Okay, so I have negative 3x plus 2y equals to 6, and I want to solve for y. So I'm going to add 3x to both sides, and I have 2y equals 3x plus 6. Now I have to divide both sides by 2, and that yields 3x over 2 plus 3. So the equation that I have in blue, it's represented, the equation of that line in y-intercept form is 3/2 times x plus 3, where 3/2 is the slope and the y-intercept is 3. The next thing that we want to do is, okay, so how do we find the equation that is parallel, that's passing through the point 6, 3? Now you want to use you may want to use the slope-intercept form that we just learned in a previous lesson, I should say. So now, if you recall, the point slope form is y minus y1 equals m times x minus x1. So we have enough information to plug this into this equation. So we have y minus, we'll say that y1 equals to 3. Now we have the slope equals to 3/2 times x minus 6. if we want to find it in y-intercept form, we got to solve for y. So I'm going to go ahead and first use a distributive property. So I have 3/2 x minus, I have 3/2 times 6, right? So we can cancel out this here. So we have y minus 3 equals 3/2 x minus 9. Now if I solve for y, I have y equals 3/2 x minus 6 after adding 3 to both sides. So now we say that the equation of the line in red is y equals 3/2 x minus 6. And notice that both equations have the exact same slope, but their y-intercept is different. And if we look at what we had just drawn before, it actually indeed, the line that we'd roughly graphed, the y-intercept is -6. Now let's take a look at perpendicular lines. Perpendicular lines, just read this out. So perpendicular lines will say that two distinct non-vertical lines are perpendicular let me just rewrite perpendicular if and only if their slopes have a product of -1. So in the equation that we had before, let's try to work with the equation that we have before with the same equation. So in the previous equation we had y equals to 3/2 x plus 3. Now let's say that instead of having a perpendicular line, we want to find an equation that is instead of having an equation that is parallel, we want to find an equation that is perpendicular to the line. Let me just remember what points I chose. So the previous points that I chose, we had 6, 3. So we say now we want a line that is perpendicular to the points 6 for the x and 3 for the y to these coordinates. So what I will have to do is now, I'm kind of a little bit a step over here, so I have to know that the slope for this equation, for my first equation, is 3/2, right? Now, if I want the product, so what I'm saying is that m1, so the slope of the first line, times the slope of the second line should equal to -1. How is that going to happen? So if my slope is 3/2 for the first line, what I have to multiply it to make sure the second slope, what does the second slope need to be to get a product of -1? So I have to multiply by the reciprocal of the first slope, by the negative reciprocal of the first slope, right? And that will give me -1. So I find out that m2 must be -2/3. Now I can now use the point slope form again because I have a slope and I have a point, and I can find the equation of the perpendicular line. So if I have y minus y1 equals m times x minus 1. I go ahead and plug in my points. Y minus 3 equals negative 2/3 times x minus 6. So I have y minus 3 equals negative 2/3 x plus 4. So if I add 3 to both sides, I have y equals negative 2/3 x plus 7. So now I have found that the equation perpendicular to the line y equals 3/2 x plus 3 is shown by this equation that we just found. And if we look at this, the multiplication, the product of the two slopes, that equals -1, and that ensures that we do have a perpendicular line.